Good evening, everybody. Thank you very much for inviting us along to your meeting this evening. I'll introduce myself first of all. My name is George Donaldson. I'm the current chairman of the National Insulation Association in Scotland, and also fortunate enough to sit on the National Insulation Association board for the UK. We've been asked to come along and speak to you tonight about some of the plans that you'll no doubt be aware of that the Scottish Government have for upgrading older properties and insulating them accordingly, specifically pre-1919 buildings. What I'm going to do is we will have a bit of a question and answer session towards the end, but I'm going to start off by handing over to my colleague Wilson Shaw, who is also the Managing Director of BC Insulations, to take you through what our synopsis is and how we've been handling and dealing with pre-1919 buildings. If I can now pass you over to Wilson, please.
Okay, thank you, George. Can you hear me okay? Yeah. Right, okay. Been asked along, as George says, to talk about internal wall insulation in pre-1919 stone properties and other solid walls that may be available in the Scottish Borders area. So if we have a look first of all at the bigger picture, as George mentioned, we are being encouraged to look at a whole house approach. So whereas IWI, internal wall insulation, would be the primary measure, there would also be other secondary measures that any surveyor or firm worth their salt would look to pick up along the way to contribute towards a whole house approach. These would include room in the roof solutions for the attic rooms, loft insulation, flat roof solutions either externally or internally fitted, cavity wall solutions perhaps in an extension at the back perhaps, underfloor insulation, external wall insulation might be an option for walls that aren't particularly, they don't have any obstacles internally in terms of kitchens and bathrooms. Would be good for IWI, but if they do have obstacles internally and they're not a stone facade, perhaps they're already rendered, then maybe external wall insulation could be an option for gables or the rears of buildings. And of course, that would all start with a survey. Now, when we look at solid walls in Scotland, we have generally two types that are of the age that we're looking at. So we've got solid stone construction and also solid brick. So the solid stone construction, maybe similar to the one in the picture, have been the form of construction in Scotland from roughly the late 1700s until the early 1900s. And that's what sets us out as being quite different compared to south of the border, where the use of bricks was brought in far earlier than it was in Scotland from the 1800s onwards. So we've got solid stone that normally consists of maybe a wall that's maybe 400 to 600 thick. And it would be built with usually a dressed stone on the outside and an undressed finish on the inside with rubble in between. They would use lime or clay bonded mortar to bond the stone. They would be normally dry. We would hope they'd be dry in normal circumstances, and would be finished internally with initially plaster and lath, and sometimes if they've been refurbished, they might now have a plasterboard dry lining instead. Now this compares to solid brick properties. We can see a section through a solid brick wall. These do exist in Scotland, not as often as they would in England. And they're different set of dynamics because it's a solid brick, generally with a hard plaster finish. And that means that the cold transfer will be much more severe, raising or causing higher surface temperatures than what you would get in a solid stone wall, where we've got an extra mass of the big thickness of stone, which is already better than brick because it's broken down because of the random nature of the stonework and the fairly lightweight lime mortar and rubble that's in between. Whereas with a brick wall, it's a solid brick, quite a dense brick, and then it has hard plaster finish internally compared to the stone. finish internally, which would be plaster and lath, which is set off the wall. So even that fact that we've got a dry lining that's set off the wall gives another thermal break, making the surface temperatures of stone walls and the U value starting place overall much better than brick. Check I haven't missed anything there. It's weird when I can't see where I'm clicking. Before we start looking at the details and the processes that we would propose, we should look first of all at what influences the choice of system and the materials. Cost is up there, as you would expect. Skills, and in particular the skills that are available to your locality. The accreditations that installers need to have to operate, and in particular operate within the funding streams. The regulations that apply through building control and the likes, maybe planning. Availability of the systems, which we'll cover later on perhaps. In terms of the things that we'll show you are pretty much off the shelf, whereas some of the more vapor open systems, natural materials aren't quite as available. And when it comes to thicknesses, the next bullet point, that can be an issue with these materials, these new materials as well. Local climate obviously has to be taken into consideration, as does practicalities such as will the occupant be present in the house during installation, and increasingly sustainability. Then we look at the challenges that IWI brings about. Cost is again up there, number one probably. It's not a cheap measure to install. Possibly an increasing problem is becoming skills. We are in the middle of a skills shortage, which is probably having a bit of a spike at the moment because of the post-COVID home improvements boom and the shortage of skills through loss of labour back to Eastern Europe. Mentioned accreditations, that can be quite a big barrier to entry for installers or contractors looking to enter this market. And regulations can be a challenge too. And we've already mentioned just in the chat before the presentation, the effect of PAS 2030, 2019 and PAS 2035 that have been introduced this year, let alone the building regs and other industry rules and guidelines that already exist. We have the period features from these homes, which are often the reason that we've bought the home in the first place, the availability of materials, the thicknesses that we want to achieve the U value. There might be a brochure that has a full range of thicknesses, but they might not all be available, and they certainly won't all be available in small loads. The social acceptance of the need for insulation is a challenge to our industry that is gradually beginning to turn, I feel, as people accept climate change. There's the fear of unintended consequences with reference to the normal way of doing things. The normal way of doing things, i.e. the way that complies with building regs and has all the BBA certificates and meets the requirements of the eco funding, won't necessarily be the way that the likes of Historic Scotland would like it done, and possibly the writers of the new PAS 2030 accreditations would like it done. And this is because there is a fear that we may be changing the dynamics of the building by introducing vapour barriers and the like. So we'll have a look at that during the presentation. And then the last challenge, of course, is the mess and the intrusion to the customer if they're remaining in the property. And to be honest, that's not a big deal. I think people probably get that wrong in their head. They overestimate the amount of time it's going to take and the mess. And the systems we'll look at tonight are actually pretty quick and small in terms of intrusion. You know, they're not very dusty at all, and can be carried out quite easily without someone having to decant. So if we start by looking at the overlining option, that's the one that we're really proposing here tonight. The overlining option is basically where we overline the existing wall insulation, the existing wall covering with a new insulated plasterboard. And there's a few pictures there just to show you what that looks like during the process. As you can see on the top left photograph, it'll be a plasterboard with an insulation backing, and the insulation on the back will be a foam insulation that could be polyurethane, polyisocyanurate, or phenolic foam perhaps. Within the insulation, or within the insulated plasterboard, there will be a vapour barrier right behind the plasterboard, and that is considered critical in the old school way of thinking to keep the moisture on the warm side of the building. So there's a bit of a graphic just to show you what it looks like. So we would have the insulated plasterboard going either directly on top of the existing wall lining by mechanical fixings or acrylic adhesive, or in some cases that existing wall lining might be strapped and we fix the new board onto the straps. As I said, this method is reasonably cheap in comparison with other systems. It can be carried out in a typical home, maybe between 2 to 4 days, because it uses a wet plaster finish instead of Ames taping. It keeps the dust to a minimum, and it's really not a big problem to install it going on a room by room basis. All this is based on the assumption that we're not doing the kitchens and bathrooms, of course. If we're removing the kitchens and bathrooms, then there would be more of an inconvenience to the people in the house. With the system shown on the graphic, if that board was, say, a 62mm board, we would be not only achieving but surpassing the 0.3 U value that is our goal to hit for various reasons, including the funding streams. If it was strapped, that would take it up to 85. And that might be down from a typical 2.1 U value starting place for a hard plastered stone wall or a solid brick wall, and 1.38 for a dry lined stone wall, similar to the one in the picture. Where walls are hard plastered, it becomes critical that they are strapped before fitting the boards with screws. That usually comes from the system designers, and you will note I've said system designers and not manufacturers, because these days it's a system designer that's the important thing. Because they retain an ownership of the detailing and the warrants and the training, whereas the manufacturers just make the boards. And it's them that will generally stipulate that we need to use straps, and sometimes even a DPC stapled to the back of the strap. And the reasons for that is to, on a hard plastered solid wall anyway, is just to negate any chance of any moisture penetration coming through that wall. It can also serve as a beneficial service void, should anyone be looking to use the opportunity of an IWI installation to rewire or repipe some of the building. As I said, typically bathrooms, kitchens and areas behind boilers wouldn't generally be done at the moment. This is having more, or this way of thinking is having more and more pressure applied to change it. Although currently it looks like the new PAS and the IWI guide that's coming out to accompany it will still allow you to leave kitchens and bathrooms uninsulated. And to me, that makes sense, because I don't think there's any world where people would be willing to rip out their kitchens and bathrooms to install internal wall insulation to their whole house. And I don't really see the risk of doing it the way we do it just now. We've had a couple of thousand plus installs and had no issues of surface condensation on kitchens and bathrooms that weren't treated. So I think as long as we are sensible and we follow condensation risk assessments and the like, then there's no any danger there. The systems, as you can see in the photographs, allow for the protection and retention of the period features within the properties, sometimes by creating a clever detail like the cornice, where we angle it back, or just by simply profiling and running new timbers to match what was there already. So where there's a will, there's a way. As I said, typically, 3 to 4 days, we can have an average house installed. And that process would include having to take off radiators and electrical sockets and switches temporarily and putting them back on once the job's done. What they'll have almost instantly, in fact, not almost instantly, what they'll have instantly will be a fast response time to their heating. And that will be very noticeable. It's not uncommon for a customer to even say halfway through the job that they've noticed a difference in the rooms that are being completed almost the minute it was done. And if we're looking to put more of a positive spin on things, quite often external wall insulation is sold on the basis that it gives the house a facelift, and so it does. But internal wall insulation is going partially towards a full refurbishment. And I would encourage any client to consider, when they've already got the intrusion in the house of an IWI installation, to think about having the other 3 walls plastered at the same time, and maybe even have the other timber finishes renewed, so that the whole room is sharp and tidy, having had a refurbishment. The typical scope of works, if we look at a typical job, layer protection, very important in an occupied house. That might be protection to the carpets and also dust sheets going over any furniture. Temporarily make safe and remove the electrics and the radiators, remove the timber finishes, and then set about overlining the walls with the insulated plasterboard system. On completion of that, the skirtings, new skirtings and facings would be put on, and then the wall would be finished with a plaster skim coat. Now, it could also be done the other way, where we skim the walls first and then come back for the joiner finishes, but often logistically it's easier to do the joiner finishes in one visit while they're there lining the walls. And then once everything's done and plastered, the radiators and electrical fittings get reinstated and tested. Couple of slides just to show how easy it is to retain the look of a room, even with the most impressive cornicing. In this picture, you can see that the client has opted to retain the window shutters, or it might even just be timber paneling, I can't remember, and didn't want the facings touched, so we just cut the system round about the window and at the cornice level on both these slides. You can see that the angled detail looks fine. This was actually a picture post-installation that was used by the estate agent selling the house a year later. Now, if we quickly just look at other options that people perceive as being an option, you've got the strip, insulate and reline, and I think this slide says it all. If you just look at that picture with the guy wearing the full face respiratory mask with the battery powered function to give him fresh air through the filter. This is why we don't want to do this in someone's house. We would have to strip the wall back. Then you have to generally repair some of the timbers that are broken during that process. Then you're going to insulate between the frame with insulated or foam boards with foil lining. Tape all those joints to maintain the vapour barrier, put in pads for radiators and the like, and then sheet and apply the timber finishes. So there's a lot of stages going on there. And as you can imagine, that takes a lot longer. And in terms of maintaining the room size, well, you'll maybe save an inch because although you're reclaiming maybe 50 to 60 millimetres, you then have to frame that out, and the framing has to be 25 millimetres off the stone, and the frame has to be thick enough to hold 80 millimetre boards roughly to hit the U value, and then to cut out cold bridging, you've got to cover that with an insulated board. So very quickly, anything that you've salvaged in terms of reclaiming the space of the plaster and lath, you've used it up again in the new build up. So it's not really the main reason for wanting to do that. You might want to do it this way if you've got a rot problem or an infestation problem. That means you really need to be stripping out the old timbers, but I can't really think of another way to justify it. Even a service void, yeah, well, you would get a service void, but I still don't think it'd be worth it. If I was putting my Historic Scotland hat on, I would say this would be the method you would have to go down if you were going to use natural materials with hygroscopic properties to create an open cell, vapor open wall lining. Of course, you wouldn't use the foil-backed rigid boards. You would use sheep's wool or wood fibre or hemp. But this is still the way you would do it. You would frame it out, insulate, and then you would line it with a board that, again, didn't have a vapour control layer within it. These systems, I mean, the natural systems, would be very expensive. They would be thicker because they're just not as good thermally as the man-made materials, unfortunately. And they wouldn't be readily available, and certainly wouldn't be available in the range of thicknesses that you can get the man-made materials in. And a few slides just to remind you of how much of a mess and time-consuming it is. And that takes us on to the last option that people still think is an option, and that is the injected option, where people would think we could just simply inject an insulation behind the gap that's already there. It is possible. It can be done. We've personally done it a few times on case studies for Historic Scotland and the like. And we even built a test rig in our training centre just to see behind a clear perspex finish how well the bead found its way into all the nooks and crannies. But the things that need to be remembered here, and the reason we would say not to do it, would be that if it's an open cell material that you propose, like some of the foams on the market that pop up on my Facebook every night, or fibrous solutions, then they're going to be open cell. So you're going to still have moisture migrating through the wall lining and right through the insulation, and then suddenly it's going to hit the cold face of the stone. And my concern would be that it would just condense at that point, and over time may result in water being absorbed into the timber dukes that are holding the frame to the wall, and maybe setting off a wee rot problem there. There's also the risk of cables overheating, and that's a possibility with any insulation. But also, if you're using polystyrene beads, then there's a reaction between polystyrene and the sheathing of the cables. Basically, what happens is the plasticizer from the cabling starts to migrate towards the bead, and it makes the cables go brittle, which again is not something you would really want to start happening where you can't see it behind your walls. I mentioned briefly the foam systems there, and I do get really frustrated when I see them selling their system for this use, because I know if you dig into the BBA certificates, the British Board of Agreement certificates for these systems, it will tell you to use a vapour barrier, and it irks me to see them selling this solution without insisting people then line their walls with a duplex plasterboard or the like. So buyer beware. From the tests that we did, I would also say even with bead, which flows almost like a liquid, it's amazing how quickly it can snag round about any snots in the cavity behind the plaster lath, or any bits where the timber lath has perhaps been broken or sticks further back than the rest. So that's something to be wary of as well. And at the end of the day, do you know what? Injecting that cavity with grey bead or a foam, you might only be hitting a U value of 0.8. We're trying to get U values of 0.3, so we're coming nowhere near that with an injected solution. Not quite IWI, but it kind of is in many ways. We've got the rooms in the roof. The rooms in the roof, or attic rooms, bring in some more challenges: tight spaces, thin framed walls, slopes. But there's no really no other way about it other than either IWI in it or getting into the attic to do it with glass wool. So this is a slide stolen from the Room in the Roof guide that forms industry guidance, and it just shows you how in an ideal world you would do it. You would use glass wool along the traditional loft space. And if there was enough space to get in there, maybe look at doing it up the half-height walls. You would use loft insulation on the top loft, and then you would oversheet the slopes with an insulated plasterboard. This means of doing the slope is the only way that's now permitted in our industry. In the past, people were sliding boards up or stuffing glass wool down the slopes. That's no longer permitted in the industry, and that's because it was leading to problems with people blocking off the ventilation, or if it was rigid boards, just cutting them so narrow so they could slide them that they weren't making any difference anyway. The gaps at the sides were too big. Typically what happens in reality though is because this area in the eaves is too small, we end up having to line the half-height walls anyway, and quite often the ceiling gets lined to where the head height permits, just due to the fact that the loft above a room and the roof is normally so small. If you can use glass wool, we would cross-lay it the same as any loft, but it's very tight in a space like that. Where we can get into the eaves lofts, then to use wool in those, then it should be insulated to the depth of the studs where possible, and then it should be insulated over the studs in accordance with that guide, and then some form of membrane should be put on to hold it in place, and any hatches into that space should be insulated as well. And of course, any pipes and tanks should be insulated and spotlights hooded, as with any loft scenario. Sloping roofs, as I said, we would overline them with an insulated plasterboard, and similarly with dormers, we would look to overline the cheeks of the dormer and often the ceiling, because there's no access to that roof space, or it is a flat roof. Typically, we'll find that it's a struggle to get an insulated board on to the cheeks, so we might be stepping right down to the thinnest board available, which is 22 millimeters. And another option, if push came to shove, would be to strip off the existing lining, insulate the frame that's there, and then reline. And in that scenario, you really need to make sure you put a vapour barrier behind the plasterboard if it's just plasterboard going on. But even then, you'll still have the risk of the thermal bridging of the timber frame, and that might, in the extreme circumstances, start to grin through as a cold spot. So you try and get an insulated board on there wherever possible, even if it's the thinnest one on the market. So I'm sure I've taken up enough of your time with that. It's a bit of a quick one through the options that we would recommend.